Gentlemen, so first we're going to do a little bit of a review on what we talked about last time with our circles. Okay. So the first example here, I need to find x. How am I going to find x?
You know that one's
the right angle triangle.
Yeah, it's the right angle.
What were you going to say? Do I know?
What?
You said.
Well, first I want to do the review, and then I'm going to do my own stuff.
Yeah, that's fine.
I just forgot my jokes.
How about this side of the room? How do we find x?
Come on,
They
guys.
gave you the answer. Instead of you were listening, they gave you the answer.
Yeah, it's a right angle triangle. It's 60 degrees.
Yes, this angle there, 90-degree angle. Because when you have a semicircle, so this would be our semicircle here, the angle out on the outside of the circle will always be 90 degrees. So this one here is 90 degrees, which makes x equal to 60 degrees. Right? 60, 30, 90 adds up to 180. This one here, O marks the center of the circle in case the picture isn't very clear. So that's the center of the circle. I have 40 degrees. How am I going to find y? There is a right angle. That is correct. This angle here would be a right angle. So it's 50. Now there is one other way that we can do this. Using a different rule, but, well, not really the rule, but rather the proof to solving these things. And it's the fact that all of these are the same size. Because if this is the center of the circle, each one of those is the radius, which is always going to be the same. So then that makes this 40 degrees, this 50 degrees, and that 50 degrees. So either way is fine. So, for those of you that want to do the extended parts, there are some more circle properties on page 409 and 410. I'm not going to cover them now. I'll probably talk about them later when we start reviewing for the IGCSEs, but for now, I'm just going to skip those. So if you want to look at those, you're more than welcome to. So what we're going to do is we're going to talk about locus, or the plural of locus, which is Loci. Okay? So, a locus is a set of points that obey a certain rule. Usually those rules involve being a certain distance from something. Okay, certain distance from a point, certain distance from a line, and so on and so forth. So this one, for example, as we have the locus of points given at a distance from a fixed point. So that that point there is my fixed point, and I'm going to use my handy dandy compass here, and that circle would be the locus of points. So those points are whatever distance we call this. We'll just call that D, right? They're all the same distance from that point. So that is my locus of points for that example. Okay, makes sense? Not too hard yet.
Why not the D?
Great. So the locus of points at a given distance from a straight line. So this one, I don't need the compass for this, but if we have just a straight line, any straight line really, this is the locus of points that would be a certain distance, 1 centimeter, say, 2 centimeters, something like that, from this line. So it would look something like this. Right? So if I have this line and I say I want the locus of points, distance D from that line. Okay? So it's just a matter of measuring the distance in 2 spots and then drawing a line. Make sense? No questions so far? And then the next one, the locus of points at a given distance from a line segment. Now this one is only different from this because a line segment has two ends, right? Our line there goes on forever. That's why we have the arrows on each end. But a line segment only goes so far. So for the locus of points, the points actually curve around the ends of the line segment. So I know this one's hard to see, but it goes around the top just like this one, only when you reach the end, it curves around. So the distance from the end of the line to the outside here, again we'll call D, is going to be the same distance, oops, that's not straight at all. It's going to be the same distance there from the line. So this distance D just curves around the outside. I'm going to shut the door. Man, that is a strong smell of perfume going on over here.
In here.
Over there somewhere.
It was sprayed on everybody.
I'm sure it was. I didn't smell them because I walked by you. So
That just smells.
great. I don't know. Did you all have gym earlier?
Yes.
Okay, so now I get the why all the smelling. Okay. Best part is all of that conversation is going to be on my video, so it's going to be awesome. Okay, a couple more. So the locus of points equidistant from two given points. Now for these ones, you have to have a compass to properly draw your points. So I'll show you this example. There it is. And I have 2 points, A and B, and I'm trying to basically draw a line of points that will always be equidistant from these 2 points. So they will always be the same distance. So in order to do that, we have to use a compass. So I will actually show you this. I'll draw a line. So let's say the end points are my 2 points, A and B. A and B. And I want to draw a locus of points equidistant, meaning it's the same distance from A to B. So to do that, I have to use my compass here. Okay, now mine here is not big enough. I don't want that. So I need to make it bigger here. There we go. So if this is my point, I put one end here, and I will draw a curve like this. Then I will move it to my other point, and again I will draw a curve like this. And where my 2 curves meet, that is where I'm going to draw my line. So this isn't going to be quite perfect. Oh, that's not bad at all. So this line here would be my locus of points, equidistant from A and B. Okay, so you put your compass on both ends, draw a curve, making sure not to change the size of your compass, right? Compass will always have to stay the same distance, right? Like I didn't move this, whoops. I didn't move this closer or farther. You have to keep it in the same spot for both points. Then you draw your 2 curves where they meet. That is your locus of points. So this is my locus. Is that one clear? Okay. Let's move this out, okay? So the last one, locus of points equidistant from 2 intersecting lines. So this one looks like that. So we have 2 intersecting lines, and I need to draw something that is equidistant from both of those lines. Bisector? Yes. So what this is this is the bisector of the angle. So it is done in a similar way to this one. So I will show you over here how we do that. So we have 1 point here, 1 line here. Let's make that actually close enough. Okay, so these are my two lines. We'll call this A, B, and C. So I need to draw a locus that is equidistant from both of those lines. And what you're drawing is the bisector of this angle. So for example, if this angle is 60 degrees, you're drawing a line that cuts it in half. So you have 30 and 30.
Remember, at first you were drawing one locus and from the points, then you were drawing 2 more.
Yes, you're about there. So I need to bring, actually, I have it. Right. So we take my handy dandy compass here. So how you start is, move this in a little bit. You start at the intersection point and you draw a line.
Yeah, and then you are
Now-
drawing 2 more locuses from
Then
points.
from where that curve meets each line, you draw another one. Here, then you go to this line, you draw another one, and where those two lines meet, again, is where you draw your line. So from that intersection point through that intersection point. So this line here, let's make this one, come on. We'll color this one blue or something. Blue's good. This is our locus.
Can you stop, David?
David, I can be mean to you today.
Okay,
No, you shouldn't.
let's not be mean to each other.
It's Friday.
You have to
every
be
night
kind
Friday.
next week, you know? I won't be, because you're not being kind. Oh wow, I'm gonna be kind next week.
Oh,
Is it a like bi-weekly basis? Your kind one mean another, kind one mean another. Okay,
Yeah.
interesting. But are there any questions about math? Not who's
I
next
have
to
a
do it.
question.
Okay.
David, why you're so mean?
From what language is the word locus derived?
I don't know.
Loci.
Sure. Probably. What do you call it?
Latin
That's the one.
or Greek?
Sure.
It's great.
Latin or Greek. We'll look it up later. Any other questions?
Lotus.
Okay, children. Shh. Stop for 1 second. If there are no more questions, then I'm going to end this here. How many of you have a compass?
Not with me right now.
But in general, you own a compass.
I just don't have the tip.
Well, that doesn't help. But for this, you will need one of these. And for the test, you will need one of these. And we don't have any extra ones here at school. I can see if I can order a few. We'll see what we get. Okay? So then, for now, you can open up the book. Yes, you're going to work out of the textbook again. To page, where are we? 412.
Can I go downstairs for my worksheets?
Okay? And you can work on the Loci.